So let's have this complex fraction up 3 plus 1 over 5, and down you have 4 divided by 3 over 2 minus 2. So this is the numerator, and this is the denominator. And as you can see, the numerator has fractions already, 1 over 5, and this is also the denominator has also a fractions already. So that's why it's called a complex fraction. This whole thing now is called a complex fraction. We need to simplify each one separately. So we need to look at the numerator, okay, and simplify it. And also you need to look at the denominator, okay, and also simplify it. So if I simplify the numerator n first, then n equal what? 3 plus 1 over 5. And in order to add fractions, I must have what? Common denominator, right? But what is the denominator for the 3? It is 1. So this is actually 3 over 1. I have to make it what? I have to make it 5. So this becomes 3 multiplied by 5 and the 1 multiplied by 5 in order to rewrite this fraction in order to have a denominator 5. Now I can add with the 1 over 5 because now the denominators are the same. When the denominators are the same, this is the same also denominator at the end, the result, but I actually add the 15 and the 5. Okay, I actually add the 15 and the 5, so it becomes 15 plus 1, 16. 16 over 5. The next is to look for that denominator. What happened to the denominator here? I'll just call it d. Okay, the denominator d here. What about it? The denominator can be simplified as you have division and you have subtraction. If you have division and subtraction, which one you do first? Division. The division. So you should divide 4 divided by 3 over 2 first. But how do you divide anyway over fraction? You have to convert it to multiplication. So this is going to be 4 times what? 2 over 3. Okay, so you just make this a multiplication and then you subtract 2 at the end. So when you multiply, how do we multiply? We multiply numerators together and denominators together, right? But what is the denominator here? Remember, this is actually 4 over 1. Okay? So that means what? That means it's going to be 8 over 3. And then minus 2. So that's how you multiply. You have to multiply numerators together and denominators together. When you subtract now, you must have a common also denominator. The denominator here is 3, but the denominator here is 2 or 1. The denominator is 1. This is actually 2 over 1, right? So you have to have a common denominator. So you have to write this as 8, you should write this as 8 over 3. And you should write the 2 as 6 over 3. And then the answer will be 8 minus 6. 8 minus 6 is 2. So that will be 2 over 3. Okay? So the numerator is 16 over 5 and the denominator is 2 over 3. Now you're going to divide them. I got the numerator, I got the denominator. I need to divide them. So that now the numerator divided by the denominator is actually 16 over 5 divided by 2 over 3. And again, I will convert this division into multiplication. So again, I'm going to write it as 16 over 5 times what? Times 3 over 2. So I converted this division into a multiplication by inverting this fraction upside down, became 3 over 2. And now when we multiply one more time, it's like a practice of solving, many fraction problems. Keep adding, multiply, divide, and then add again, and then subtract, and then divide. And so it's just like a good practice of how do we do these operations. How do we multiply now? Did you forget? 16 times 3 and 5 times 2. But when you do that, you should factor and also remove common factors. So if you actually factor the 16, it will be also actually, I know there's a 2 here. See that 2 here down? We cancel the 2, one of the 2 in the 16. Nothing else will happen. So you can do that from the beginning. You can just cancel this with this. You just have a 1 here and you have an 8 here. Because I just took this 2 and I took 2 from the 16. I know this will happen when I multiply. Okay? Yani the style of writing can be different, but what's actually happening is the same. You're still factoring and removing the common factors up and down. And then the answer now will be 24 over 5. 24 over 5 because I multiplied this 8 times 3, I multiplied 5 times 1. Okay, it's a long question. It's a good practice to learn. If you know how to solve complex fractions, then you know everything about fractions. Then you should know everything about fractions.